Hi there! In this video, we're going to talk about geometric probability. So what is geometric probability? Typically, it's finding the probability of like throwing a dart or throwing a ball or something landing inside a small shape that's inside a big shape. So let's just talk really fast about what probability is. So probability is the chance of something happening. And so to find the probability of an event, okay, whatever you want to happen, probability is always going to be a number between 0 and 1. So, and it's usually reported as a percent. So like it has a 10% chance of happening or a 20% chance of happening. But when you mathematically figure it out, you're going to get a decimal, a number between 0 and 1, where 0 would be like 0% and 1 would be 100%. It's always going to happen. So when I'm finding the probability of an event, I want to find what I want to happen goes on the top of my fraction. And then on the bottom is the total number of ways that my event can happen overall. And I divide the two and I get a number between 0 and 1. When we're talking about geometric probability or probability in geometry, and we're using area of shapes. So the probability of, let's say, I like to think of this as if you go to like the fair, right? And you play those games. Like, what's the probability of winning? Okay. So you want to take like the area of the shape that you're trying to, throw the dart or toss the ring or land the ball or whatever. You take the area of that shape and then you divide it by the whole game board area. All right. So we kind of just want to review our area formulas. So I put them all out here. So this first one is going to be area of a square. Okay, this next one is, here I should highlight these. So we have area of a square. Then we have, this one would be area of a rectangle. We have area of a circle. Area of a triangle. This last one we probably won't use, but I did put it in here kind of just for reference. And this is area of a regular polygon. It's probably not going to come up. Usually it doesn't in this type of problem, but just in case you need it as a reference, it's there. And how I wrote it out is you take your regular polygon, if you break it up into triangles using the central angle, you take the area of one of the triangles, which is 1/2 base times height, times the number of triangles that you have. But like I said, you're probably not going to use that one. So I got a couple examples for you. So this one says, so here we're playing darts. A dart hits the circular dartboard shown below at a random point. Find the probability that the dart lands in the shaded square region. The radius of the dartboard is 6 inches and each side of the shaded region is 2 inches. So my probability is the probability that it hits the square. So I want to hit the square. Okay. So I have to find two things. Where do I want it to hit? I want it to hit the square, so I need to find the area of the square. But where could it hit? And imagine, and you have to remember and always pretend that you have excellent aim, that you're always going to aim and hit the board. Where could it possibly hit? It could hit anywhere in the circle, so I have to find the area of the circle. Okay, so when I do this, I just write out my formulas, and then I let the calculator literally do the rest of the work. So area of a square is side times side, or side squared. And each side of my square is 2 inches. So this is going to be 2 times 2. Okay. And then area of a circle is going to go on the bottom. Area of a circle is pi r squared. So pi times my radius, which is 6 squared. And you probably have to do some rounding in here because you're using pi. We're going to round to the nearest hundredth, which is 2 decimal places. Okay, so I'm going to literally type this in my calculator. So I'm going to go open up my Desmos calculator. And I'm going to literally type in 2 parentheses 2 divided by pi times 6 squared. And I get this number, 0.0353. 0.0353. So I come back and write this down. Equals 0.0353. Round to the nearest hundredth, that's this space right here, so I look one over, and because it's a 5 or bigger, I'm going to round up, so 0.04. If you change that into a percent, it's 4%. So chances of you winning this game, not very good. 4% is pretty small. So this is the same as 4%. Okay, and you can report your answer just depending on how your textbook or your curriculum is asking you to, as a percent or decimal. Either one is correct. So just depends on how they want it reported. Okay, let's try one more. So a dart hits the circular board shown below as a random point. So I'm throwing darts again. Find the probability that the dart lands in the shaded circular region. So now I want it to land in the circle, not in a square. So I want the area that it hits the blue. I shaded it blue. So I want the area of the blue circle. Okay, so where do I want it to land? I want it to land in the blue circle. So I need to find the area of the blue circle. And where could it land though? It could literally land in the whole circle. Again, we're going to pretend I'm actually remotely good at darts where I'm always going to hit the board. And I'm going to have the area of the whole circle. Okay, so we know the area of a circle is pi times r squared. So I'm going to hit pi. My radius of my small circle, it tells us the radius of the shaded region is 5, and it's in the picture. So this would be 5 squared. Divided by the area of the whole circle, the radius of the dartboard is 11. So divided by 11 squared. So I take this, I plug this all into my calculator. Pi times 5 squared divided by pi times 11 squared. So I open up my calculator. Okay, I do pi times 5 squared, all divided by pi times 11 squared. Okay, and I get 0.2066. All right, equals 0.2066. We're going to do like we did the last one, round to the nearest hundredth with just this location. I look one space over. Because it's a 5 or bigger, I round it up. So this is equal to 0.21 or 21%. A little higher than the last one, so you have a little more chance of winning in this game. So that's all you're doing. You want to find the area of where you want it to land, that shape, whatever shape it is, divided by the area of the whole game board. If you have any other questions, let me know. Good luck.